So again, our two sentences that we know are two equivalence statements. 1 mole is 6.022 times 10 to the 23rd units. And we also know that 1 mole is equal to the periodic table number of grams of whatever it is, whether it's just a single element or a compound. Right? This is the molar mass. So from these two equivalence statements, we can write 4 conversion factors. So these statements make conversion factors. Right? Like the thing that I'm multiplying by. So from the purple one, I can write 1 mole per 6.022 times 10 to the 23rd units. Or I can flip-flop that and I can say 6.022 times 10 to the 23rd units per 1 mole. And the same thing is true for the molar mass. I can write 1 mole per the periodic table number of grams, or I can put the periodic table number of grams per 1 mole. This one is the molar mass. This is inverted molar mass. Okay. I'm going to make sure you guys have that written down, and then we're going to do an example problem. So that process right there is always going to be the same. When you've got grams on the bottom, you have to have moles on the top. I always go to the periodic table to find the number of grams. So for sodium, it's 22.99. Now my grams cross out. But I'm not trying to find moles like I did a couple of homeworks ago. I'm trying to find atoms. So now I'm going to take this label, moles of sodium, and I'm going to put that on the bottom. So now if I have moles on the bottom, I get to choose. This time, well, here are my two choices. I can put either grams or I can put particles. And this time, because I just got rid of grams, I am going to put atoms of Na. 1 mole, and then the number that goes in front of atoms, like we were doing earlier when I kept asking you guys, 6.022 times 10 to the 23rd. So now my moles crosses out, and I just do the math. 3.26 divided by 22.99, because that's on the bottom, times 6.022 E23, because that is what's on the top. And then I get 8.539 times 10 to the 22nd, 3 sig figs, looking back at my data, so 8.54 times 10 to the 22nd atoms Na. Is my final answer. Okay, that was kind of a lot. Any questions on that? Like, where did the numbers come from? All right, Brady, what do you got?
Sorry, I keep on hitting spacebar. I have a hotkey, so every time I raise the tongue, I accidentally press spacebar.
Oh, okay.
I'm sorry.
That's okay. I just wanted to make sure because you raised. Anyway, you're fine. You're fine. All right. Let's do one more example, and then I'm going to give you guys your homework. All right. Next problem. You are given 3.95 times 10 to the 22nd molecules of CO2. How many grams of CO2 is this? Oops, sorry, that was crooked. All right, so you have 3.95 times 10 to the 22nd molecules of CO2. So that's what you're given. How many grams is what you're trying to find? So I'm going to start again all the way over here because this is going to be a two-step problem. 3.95 times 10 to the 22nd molecules of CO2. Take my label, drop it on the bottom. When molecules are on the bottom, moles have to be on the top. And it's 1 mole, and the number of molecules is 6.022 times 10 to the 23rd. Molecules goes away. Now I need to get rid of moles. All right, moles on the bottom. I now have to choose what to put on the top. This time I'm going to choose grams of CO2, and I need to go to my periodic table to get the mass of 1 mole. So remember, this is molar mass, and this middle conversion factor is Avogadro's number. Okay, so according to the periodic table, I've got 1 carbon times 12.01. I've got 2 oxygens times 16.00. Adding those together, I get 44.01. grams of CO2 per 1 mole of CO2. And now my last thing that I do is cross off my mole label, make sure that's what I'm trying to find. It is. And now I just do the math. 3.95 E 22 divided by 6.022 E 23 times 44.01, and I get 2.8867 grams of CO2. I have 3 sig figs at the beginning, so I need 3 at the end. The 6 makes the 8 round up, so 2.89 grams of CO2 is my final answer.